Murphy's Law holds that if something is going to go wrong, it will do so at the worst possible time, in the worst possible place. For First Energy Corporation of Akron, Ohio, Murphy was in fine form in January 2011 at its Samus station in Stratton, Ohio. First Energy's Unit Number 7, 835 megawatt generator had thrown its rotor at the peak of the winter lighting and heating season. What's more, the generator was located astraddle two building bays with structural steel obstructions directly overhead. First Energy contacted National Electric Coil to perform the emergency repairs to the generator, and NEC contacted Atlas Industrial Contractors of Columbus, Ohio. It was not the first time NEC and Atlas had worked together on a generator rebuild. Atlas had successfully performed a similar feat for National Electric Coil on behalf of American Electric Power's Conesville station in Conesville, Ohio. This time, the call came in the middle of the night in the first week in January. By the second week, a bid had been prepared and submitted, and by the third week, the job had been awarded to NEC and Atlas. The first problems facing the team were decisions on means and methods. NEC's method for repairing the generator, comprised of a stationary stator housing and a spinning rotor, is to first upend the stator housing. But because of the overhead obstructions at Samus Station, the stator housing would have to be relocated before upending could occur. Atlas quickly realized that utilizing its tower lifting system, as employed in the AEP Conesville project, was not possible at Samus Station because of the overhead obstructions. The decision to use a hydraulic gantry system was quickly arrived at, and a 1,000-ton unit was soon procured from Rigging Gear Sales Incorporated. But the rest of the project would not move as swiftly. While NEC and Atlas were old hands at this kind of undertaking, First Energy was not. There were so many unknowns, so much for the client to consider. Time and expense, of course, but also potential damage to the stator housing as well as to the turbine pedestal. First Energy explained it this way: "You may do this for a living, but we sell energy, and this generator is how we make our living." Adding to First Energy's unease was the opinion of Siemens, the OEM of the generator, that the end bell would deform during the lift or while resting on the foundation during the core installation, irreparably damaging the generator. First Energy elected to retain an independent engineering consultant, who, incidentally, had never even seen a hydraulic gantry in operation. One of the first questions asked during the initial review of the lift plan was, what keeps these things from tipping over? To address concerns about damaging the stator during the lift process, Atlas hired Ruby & Associates of Farmington Hills, Michigan, which had worked successfully with Atlas on countless lifting projects, to perform a finite element analysis of the stator housing and prepare the lift plans. Based on the finite element analysis, it was determined that reinforcing plates should be temporarily installed on the stator housing during the rebuild. Even though analysis showed that the belled end of the housing could support the stator weight, to allay First Energy's and Siemens' concerns, support stands were designed to distribute some of the weight of the stator to the lower trunnions. Given the additional owner requirements, the engineering budget grew to 3 times initial projections. Despite the protracted approval process and additional engineering requirements, by mid-February, 5 weeks after initial contact, all specialized components had been fabricated and the lifting system was installed in place. The stator was now ready to be relocated and rotated. In preparation for the lift, First Energy had removed the rotor from the stator housing, decoupling the generator from the turbine. NEC had removed the existing core, comprised of approximately 750,000 individual laminate plates with a total weight of 400,000 pounds. Given the reduced weight of the empty stator, this would clearly be the easier part of the move. Fully assembled, the generator weighed 400 tons, and the plan and the engineering had to account for this. Due to the constraints of the building, Atlas employed a lift system's 1,000-ton gantry system with an overall height elevation of 40 feet, necessary to complete the upending and downending of the stator frame. Atlas also employed two legs of its 500-ton gantry, connected to Atlas's tailing fixture to act as the tailing gantry during the lift process. 80 feet of 30-inch track and 30 feet of 15.5-inch track were deployed to support and direct the rolling gantries. With the gantries and tracks in position, the next step was to install the reinforcing plates on the side of the stator and mount 4 trunnions on the stator housing. During the design phase, Ruby and Associates determined that using conventional rigging methods, high friction forces would have to be overcome during the uprighting, or there was a very good chance that the stator and lift system would lurch unpredictably during rotation as the friction between the bearing surfaces was periodically overcome. In response, Atlas and Ruby developed an innovative ultra-low friction bearing that was incorporated into the lift links. The lift links, as well as the lift trunnions and other specialty components needed for the lift, were fabricated by Atlas Steel. The lift links fit snugly over the upper trunnions and assured a smooth uprighting process, which greatly assisted in keeping the assembly in a plumb condition throughout the lift. Installation of the gantry header steel followed next. The primary lifting beams on the 1,000-ton gantry were two 35-foot W36 by 361 I-beams. The W36 beams supported two transverse W14 by 311 beams, each 12 feet long, which in turn supported a single 24-foot W14 by 311 beam to which the lifting links were attached. For the 500-ton gantry, a single 30-foot W14 by 398 beam was more than sufficient. All the rigging apparatus and lifting links were supplied or fabricated by Atlas. To assure the lifting assembly remained plumb throughout the project, magnetically attached lasers were installed on the lift links with targets on the beams overhead. Throughout the project, the laser beams could never be more than 3/4 of an inch out of the target centers. They never were. In order for the stands to share load with the end bell of the stator, as the stator gradually increased in weight due to the reinstallation of the laminate plates, shims were installed under the stands at a critical point in the restacking process. Shims were also employed under the steel grillage supporting the stator end bell to provide uniform contact of the stator bell against the steel. This ensured that stress in the stator shell was uniform, with no local stress risers that could buckle the stator housing. As always, safety is paramount in Atlas's pre-job planning and project execution. Atlas's dedicated safety manager and project management prepared and submitted pre-task planning and job hazard analysis to both NEC and First Energy for approval. All project personnel attended First Energy's site-specific safety orientation and power source locations and lockout-tagout sessions before work was begun. Once these sessions were completed, Atlas conducted its own full-scale safety orientation, including individual instruction of all project members and walkthroughs of all phases of the project. Thereafter, daily on-site safety meetings were held, assuring each team member was fully briefed and safety conscious. Next, a series of test lifts were performed to assure all systems were within acceptable tolerances. Prior to each of these heavy lift activities, Atlas and First Energy gathered all personnel involved to reinforce and run through each step of the plan and sign off on the Atlas critical lift ticket. Now, with everything in readiness, the move could begin. Atlas now attaches the tailing fixture using the station's overhead crane. Most of the fittings employed in this process made use of components originally designed and constructed for the AEP project, saving First Energy time and money on its repair. With the tailing fixture in place, the generator is moved away from the turbine in a series of coordinated vertical lifts and horizontal gantry movements to keep the stator and attached piping clear of the turbine and generator foundations. Of course, it was equally important to maintain clearance with overhead obstructions, which precipitated the need for the horizontal movement. As the tip-up operation began by raising the 1,000-ton gantry system at the turbine end of the stator, the 500-ton system was used to synchronize with the movement of the 1,000-ton system during rotation of the stator. Pre-planned hold points were built into the lifting schedule to ensure all axes of the stator and gantry systems were within allowable tolerances. Once the stator housing was vertical, it was moved to the far west end of the gantry tracks. At this point, the support steel grillage of the W14 by 176 beams spanning the generator foundation were put into position, and the lower trunnion support stands were moved into place. The stator housing was then repositioned over the stands and grillage. The gantries were lowered until the stator housing came to rest on the steel grillage, and the initial shims were installed on the lower trunnion stands, leaving a small gap so that no load would be initially transferred to the stands. From the time the lift began until the housing was safely at rest on the grillage required about 4 hours. For Atlas, the project now paused. While the rotor was sent off-site for repair and rebalancing, NEC began restacking the core with laminate plates, a procedure requiring a little less than 3 months. Once during restacking, Atlas crews returned to the job site to install shims beneath the support stands. This allowed the stands to support a portion of the additional load added during restacking. With the rotor and 3/4 million laminate plates reinstalled, the stator weight was back to its original 400 tons. It was now time to return the unit to horizontal. It's worth noting again that the unit was now twice as heavy as before. Gantry lifting pressures and the tractive effort to overcome rolling resistance would be markedly different for this part of the procedure. Once again, First Energy required the same insistence that Atlas was up to the task, requiring a string of signatures on all plan documents that reached all the way up to First Energy's vice president level. With the stator clear of the support stands, the stands and the support beam grillage were removed from the lift area. Once again, the generator was repositioned through a series of coordinated vertical lifts and horizontal gantry movements. Atlas began remobilization for the laydown on a Thursday, and by Saturday afternoon, the job was complete. The actual down end and repositioning took about 3.5 hours. In summary, Atlas completed the job with 875 hours of engineering, 740 hours of planning and project management, 280 hours for a dedicated safety manager, and 3,937 hours of direct labor. The entire job was finished with 0 safety incidents or recordables, under budget, and with complete customer satisfaction. Sometimes, helping your client understand that you have the skills and experience he needs are as important as the skills and experience themselves. Atlas took the time to reassure First Energy it was the right contractor for the job. Then it went out and proved once again that the toughest jobs take the Atlas touch.